Welcome to lesson 2 of 4 in this tutorial on the topic of electrical charge and current. This is our second video in our series of 4 lessons on the topic of current, voltage and resistance. Here are the key learning objectives for this session. First, we'll look at electrical charge, and then we will move on to calculating charge flow. Here are the AQA specification points for this tutorial. Pause the video now to have a quick read through them before we begin. The first point we will cover looks at the definition of an electrical current. Here, we can see the flow of electrons within a circuit. This is a current, which is also known as the flow of electrical charge. As we saw in the previous diagram, a circuit will have many electrons flowing around it. Now let's move on to our next specification point, covering the importance of having a potential difference source. As you can see, there is a random motion of electrons in the circuit. Overall, there is no net flow of electrons. A potential difference, or a voltage, is needed for a charge to flow. If you have an ordinary metal wire without a cell or a battery, the electrons will move randomly, and there will be no net flow of charge. When a cell or battery, or a potential difference, is applied to the metal wire, the electrons will move away from the negative terminal and all move towards the positive terminal. The value for current is also known as the rate of flow of charge. It is mentioned in amperes. It tells us how fast the charge is flowing through the circuit. The faster the flow of the electrical charge, the larger the current there is. Similarly, the slower the flow of the electrical charge, the smaller the current will be. The next specification point covers the idea that charge is the same all around a circuit. Current has the same value at any point in a single closed loop of circuit. Once we have learnt about series and parallel circuits, this will make more sense. There are 2 types of circuits we need to know for AQA exams. The first is a series circuit, and the second is a parallel circuit. Within series circuits, the current will be the same throughout. Within parallel circuits, the current may vary between the different branches or loops of the circuit, but within each loop, the current is going to be constant. A current is a flow of charge. The current is the rate of flow of charge. It is important to remember that the current is the same at all points in a closed circuit loop. Some exam questions will ask you to use this fact when making calculations from circuit diagrams. Finally, we'll look at an equation involving charge flow. We can measure current using the following equation. Charge flow is equal to the current multiplied by the time. This is a short version that is acceptable to use in AQA exams as long as you know what the symbols stand for. Here are the units for this equation. The new one is the measurement for charge flow, which is coulombs. 1 amp means that 1 coulomb of charge is passing the point per second. This equation is commonly used in many exams. However, you need to watch out for the units. Sometimes, the question might give you the time in minutes instead of seconds, meaning that you have to convert. Let's have a go at this practice question. Pause the video now to attempt this by yourself. The answer is 20 coulombs. Let's go through it step by step to see how we got there. First, we need to write out the equation. Our equation, as we've seen in this section, is Q is equal to I times T. Now we can substitute in our numbers. So we want to work out Q. I is 2 and T is 10. This means that our answer will be 20 coulombs. Remember, marks are often given for the correct units, so make sure that you don't miss them out. We've now covered all the learning objectives for this session. Feel free to skip back through the video and re-watch anything you're unsure about. We have now completed Lesson 2.